We're going to look at a few tables and use these tables to try to identify which ones are linear and which ones are exponential. And we're going to do this by looking at how they change between values. So we're going to look how they change between values in the x direction, right here. How do they change here? And then how they change in the y direction. So we're going to look at that too. Okay. So when we're looking at this, it goes from 0 to 1, 1 to 2, 2 to 3. Well, that looks like I'm adding 1 every single time. So if I take 0 and I add 1, I get 1. 1 and I add 1, I get 2. 2 and I add 1, I get 3. Okay, so then I'm going to look at the bottom and see how that changes. So I'm going from 2 to 4 to 6 to 8. And it looks like I'm adding 2 every time. So if I take 2 and I add 2, I get 4. If I take 4 and I add 2, I get 6. If I take 6 and I add 2, I get 8. Okay. I'm going to look at the one on the right and see how that changes. So I'm going to do it this color and say, how does it change here to here? How does it change here to here? And then how does it change here to here? All right. So when I'm looking at this from 0 to 1, 1 to 2, 2 to 3, well, it looks like, again, it's adding 1 every time. So it's adding 1 to get to the next value. If I look at the y's, I'm going to do the same thing, say, how does it change? Well, if I go, well, maybe it's, from 4 to 8, it's adding 4. But when I do the next one and say, well, 8 plus 4, well, that doesn't equal 16. That's not it. It's not adding 4 every time, so that's not what's happening. What else could be happening? Well, maybe they're multiplying. So maybe I can say, well, it's multiplying by 2. So 4 times 2 is 8. Let's try the next one. 8 times 2, well, that would be 16. And 16 times 2, well, that's going to be 32. Okay, so they're not doing the same thing in the x terms as they're doing in the y terms. All right, well, let's look at the next one. I'm going to look at this one again and say, well, how is it changing from here to here? How is it changing from here to here? And how is it changing from here to here? When I'm looking at it, I'm going 0 to 2, 2 to 4, 4 to 6. Well, it looks like it's adding 2 every time. 0 plus 2 is 2, 2 plus 2 is 4, 4 plus 2 is 6. Okay, I'm going to look at the bottom, look at the y terms and see, or y values, and see how those change. And if I go 2 plus 2 gives me 4, 4 plus 2 gives me 6, and 6 plus 2 gives me 8. Okay, so that works. I'm going to look at the other one on the right and see how this is changing. Okay. And I'm going to say, well, it's going from 0 to 1, 1 to 2, 2 to 3. Well, it looks like I'm adding 1 every time. And that will get me to the next term. And then I'm going to look at the y's and see how that's changing. And from 1 to 3, well, if I added 2, that would get me there. But from 3 to 9, well, if I add 2, that won't get me to 9. So adding 2 is not it. I can try, well, 1 times 3. Well, that would get me to 3. And 3 times 3, well, that would get me to 9. And 9 times 3, well, that would get me to 27. Okay. So I'm trying to figure out which ones multiply the same amount each time, which ones add the same each time, and I can see a pattern here. I can see that when I'm on this right here, when I'm looking at my y's, my x's, when I'm looking at my x's, it looked like no matter which x I was looking at, right, all of my x's, they always added the same every time. So I'm going to write that down and say, well, I noticed this. I noticed that my x values add the same. Oh, wait, I should put this down here. Down here. So my x values add the same. add the same, right? Which ones add the same? And then only on the red ones, so only on the red, the y values add the same. So when I'm looking at these guys, down here, right, these added the same every time. But when I'm looking over here at this, these are not adding the same every time. Over here, these are multiplying the same every time. So even though the x terms are adding, the y ones are not. So I'm going to put that in here because I think that's important. So I'm going to say, well, the y values that are multiplying, right? So they're multiplying the same amount each time. Okay. So when we're doing this, I'm going to tell you that when I have this, we have a table we're going to fill out, and I'm going to start showing you that the things that were linear were the things that added the same every time, both for the x and the y, and the things that were exponential, well, the y values, they multiplied the same every time. So we're going to fill out this table and say, when I had x values for linear functions, so I'm going to make this highlighted in green and say for my linear stuff, my x values, well, they added the same every time. So they add the same. And I also noticed that for my exponential ones, which were on the other side, that my x values, well, they add the same too. And specifically by 1, right? Every time. And I'm going to look at my linear stuff, and my y values, well, they also added the same on this side. They add the same. But on this side, right down over here, well, we notice that the y values, well, I'm going to do this in blue and say they multiplied the same every time. So that's how I can distinguish between something that's linear and something that's exponential. Something that's linear, it adds the same every time in the x values, and then it adds the same every time in the y values. And that tells me that we have a constant rate of change. So we have a constant rate of change because it's the same adding on for everyone on top, and then it's the same adding for everyone in the y values. And for exponential, they add every time in the x values, but they multiply the same every time for the y values. And this is not considered a constant rate of change.